Hello, my name is Devanjan Chakraborty, a student of Kijuna Government Engineering College, and today we will discuss the basics of communication systems and modulation. Let's start with the introduction of communication. Communication is the process of exchanging information, ideas, thoughts, feelings, or messages between individuals or groups through verbal, non-verbal, written, or visual methods. It involves a sender, a message, a medium, and a receiver with feedback being an essential component to ensure understanding. And for in electronics and communication engineering, communication system stands for a communication system refers to a structured arrangement of components and processes designed to transmit information from one point to another. It typically includes a sender, encoder, transmission medium, decoder, and receiver. Communication system can be analog or digital and are used in various ways such as telecommunication, broadcasting, and data networks. Let's go to the next slide. Next slide, we'll discuss about analog communication. Analog communication and digital communication are two distinct methods used to transmit information. Analog communication involves conveying information using continuous signals that vary in amplitude, frequency, or phase to represent data. Examples include traditional radio broadcast and telephone calls. This method closely mimics natural signals, but is more susceptible to noise and distortion over long distances. Digital communication, on the other hand, transmits information using discrete signals, typically binary code, zeros and ones. Examples include modern computer networks and digital television. Digital signals are less prone to noise and can be easily compressed and encrypted, ensuring higher fidelity and security. The main difference lies in the nature of the signals. Analog is continuous while digital is discrete, leading to difference in quality, efficiency, and robustness. In today's presentation, we'll discuss only about analog communication. In this slide, we'll see the basic components of communication system to a block diagram. The first one is source, that is the information center that sends input message to input transducer. Input transducer then uh, uh, transform the signal to an electrical signal. The input signal to an electrical signal. Then the electrical signal passes to transmitter and through channel, which includes noise cancellation. And then the receiver receives the received signal from the channel. Then the receiver then again transforms the signal to electrical signal to output transducer, and output transducer uh, gives the output message to the destination. That is the information receiver. And now we'll discuss about the components of the communication system one by one. Analog communication involves various components that work together to transmit continuous signals. Here are the key components. Information source. The information source is the origin or the generator of the data or message to be communicated. It is the starting point of the communication process. The source could be a person, a machine, or any device that generates the message. For instance, human communication. In a phone call, the human voice is the source of the message. Computers and devices. In the case of data transmission over a network, a computer or a device is the source sending data packets to other devices or systems. The source role is to produce data that is to be conveyed, whether it's text, audio, video, or sensor readings. This is the source, information sender. Then we'll talk about the transmitter. The transmitter converts the input message into a suitable signal for transmission. It often includes an oscillator to generate the carrier signal and a modulator to impose the message signal onto the carrier. The transmitter is the initial stage in an analog communication system. Its primary role is to convert the input message, such as sound or data, into a signal suitable for transmission. As you see here, the transmitted signal produces the transmitted signal to channel into a suitable for transmission. This involves process such as modulation, where the message signal is combined with the carrier wave, adjusting its amplitude, frequency, or phase to encode the information. The transmitter also typically includes an oscillator to generate the carrier signal and amplifier to boost the signal strength, ensuring it can travel efficiently through the communication channel, which we have seen in the block diagrams. Now I'll talk about the communication channels. That is this, the communication channel. The this is the medium through which the signal travels from the transmitter to the receiver. This, in this could be air, as in radio waves, coaxial cables, fiber optics, or other media. The channel can introduce noise and distortion to the signal. This is the channel, which can be fiber optics or air or any other area, which includes the noise. The channel is the medium through which the signal travels from the transmitter to the receiver. This can include various physical parts such as air for radio waves, copper waves for telephone signals, or optical fibers for data transmission. The quality of the channel is crucial as it can introduce noise and distortion, affecting the integrity of the transmitted signal. Environmental factors, distance, and interference from other signals can all impact the performance of the channel. Then from the channel, the signal travels to the receiver. When we talk about the receiver captures the transmitter signal and extracts the original message. It typically includes the demodulator to separate the message signal from the carrier and amplifier to boost the signal strength. The receiver is responsible for capturing the transmitted signal and recovering the original message. This process typically involves demodulation, where the carrier signal is separated from the message signal. The receiver may also include filters to remove any unwanted noise and amplifiers to strengthen the weak received signal. Its goal is to accurately reconstruct the original message as close to its original form as possible, despite any distortions introduced during transmission. Let's talk about noise that introduced in the channel. Noise. Noise refers to any unwanted variations or disturbances that affect the transmitter signal. This can arise from a variety of sources, including electrical interference, thermal agitation, and other environmental factors. Noise can distort the signal, making it difficult for the receiver to accurately recover the original message. Reducing noise and mitigating its effects are critical challenges in designing and maintaining reliable analog communication systems. Now let's talk about uh, output transducer. An output transducer is a crucial component in communication system, particularly in analog communication. It is responsible for converting the electrical signal back into a form that can be perceived by humans or other systems. Essentially, it is transforms the output electrical signal from the receiver into an audible, visual, or mechanical form. For example, in a radio, a speaker acts as an output transducer, converting electrical signals into sound waves that we can hear. In a television, the screen serves as an output transducer by converting electrical signal into visual images. Output transducers ensure that the transmitted information can be understood and utilized at the receiving end. Now let's talk about the last, that is the destination. That is the receiver, which receives the information signal. The destination is where the received information is delivered and used. It is the end point of the communication system where the final output of the communication process is intended to have its effect. Human. In voice communication, example phone calls, the destination is the person who listens to the message. In this case, the message is decoded and heard via speaker or headphones. Display or storage. In some communication system like television, broadcast, or digital media, the destination could be a screen or a storage device where the received data, video, text, etc. is displayed or stored for later use. The destination ensures the proper interpretation and use of the received data, which could involve further processing, storage, or triggering specific actions in an automated system. Let's talk about the next topic, that is modulation. Modulation is the process of varying one or more properties of a carrier signal, such as amplitude, frequency, or phase, in accordance with the information or message signal to be transmitted. It enables the transmission of the information signal over long distances and through various media efficiently. Here we can see how modulation works. This is message signal which modulates and becomes modulated signal. And the modulation happens via carrier signal. Let's see the advantages of modulation. What is the use of modulation? Modulation is the process of carrying a carrier signal to transmit information. It is essential for efficient and reliable communication. Here are some key advantages. Increased signal range. Modulation helps transmit signals over long distances by shifting them to higher frequencies, which reduces power loss and signal degradation. Reduces antenna size. The size of an antenna is inversely proportional to the frequency of transmission. By modulating signals to higher frequencies, we can use smaller antennas. Minimizes noise and interference. High frequency signals are less affected by noise and interference compared to low frequency baseband signals. Enables multiplexing. Multiple signals can be transmitted simultaneously using different carrier frequencies. Frequency division multiplexing FDM, making efficient use of the available bandwidth. Facilitates long distance communication. Low frequency signals cannot travel long distances efficiently. Modulation allows signals to be transmitted over vast distances via wired or wireless media. Improve signal quality and reliability. Techniques like frequency modulation and phase modulation provide better immunity against distortions, ensuring clear signal transmission. Efficient use of bandwidth. Modulation techniques optimize bandwidth utilization, making communication system more efficient. Supports different transmission media. Modulated signals can be transmitted via various media like coaxial cables, optical fibers, and wireless channels. These are the types of modulation. The two types of modulation are continuous wave modulation, pulse digital modulation. For continuous wave modulation, there are two modulation, amplitude modulation and angular modulation. And see, this angular modulation is in two parts, frequency modulation, phase modulation. And for pulse digital modulation, there are two, digital modulation, analog modulation. For digital modulation, there is pulse code modulation. And for analog modulation, there is pulse amplitude modulation, pulse duration modulation, and pulse position modulation. Now, the conclusion, what we know from this PPT. In this presentation, we explored the fundamentals of communication system and the importance of modulation. A communication system enables the transmission of information over various channels, ensuring effective and reliable data transfer. Modulation plays a crucial role by enhancing signal strength, reducing interference, enabling long-distance communication, and optimizing bandwidth usage. Understanding these basics is essential for developing advanced communication technologies from radio and television broadcasting to modern wireless networks. As technology evolves, efficient modulation techniques will continue to drive innovations in telecommunications, including faster, more secure, and more reliable communication systems. So that's it for this. Thank you for watching.